In this video, we'll do a little more practice with dot product. We're told this vector 16i plus k plus 5 times j. I'm going to write that again. 16i plus k plus 5 times j. Just double check you're transcribing. It's perpendicular to this guy, ki. And then we have minus k plus 3 times j. And we're told it's perpendicular. So therefore the dot product is equal to 0 or undefined. So let's have a look here. It's going to be the I by the I, 16 by k. And then we have plus k plus 5. It's going to be a minus actually, because there's a minus there. We need to put the minus in somewhere. So we put the minus in here. K plus 5 by k plus 3. So we're going to get a quadratic. You can see we're going to get k squared. So if this is equal to 0, let's multiply it out. We get 16k. Keep the minus there for now. K squared plus 8k plus 15. All the signs are going to change with the minus. So we're going to have minus k squared minus 8k minus 15. If you imagine bringing them to the right and making them positive, k squared plus 8k plus 15. We'd have to bring this guy across as well, minus 16k. That would all leave 0 on the other side. So we're going to get k squared minus 8k plus 15 is equal to 0. With these quadratics, you never really see the answer until you get to the end. Has to be k times k. You can see why you needed to factorize at junior cert. You should be able to even cert higher level maths and applied maths to see that 5 by 3 is 15 and 5 and 3 is 8. And they're both minus, with the minus sign in the middle and the plus sign at the end. I'll repeat that a few times and then it just becomes second nature to you. So here we have two values for k. K is equal to 3 or k is equal to 5. At junior cert, you may have been told to write k minus 3 is equal to 0 and solve it this way by bringing the 3 across, but we're now at higher level applied maths. No need for this anymore. And we're told k is an element of real numbers here. Question 10, just read it carefully. Find the sine of the acute angle. Well, we know we can find the cause of the angle, so we can find the angle. Let me just get the sign of it. So just read the question carefully. They're just trying to throw a spanner in the works here. So the dot product, the cos of the angle, cos of theta. If you want to write out one extra step, is going to be 7 by 5. My 7 by my 5 plus my 1 by my 5. All divided by the magnitude of each of these. Can you see the first one is root 50, 49 and 1. Root 50 times 25 and 25 is also root 50. So type into your calculator the inverse cos 35 plus 5, 40 over 50, 0.8 again. We've seen this angle coming up repeatedly. So the angle here, we want to call it A. Let's call A is equal to, and this will give you 36.869, let's say 87. So let's just look before we get the sign of that angle. Let's just look when we have the ratio here, rather than using our calculator. This is equal to 4 over 5. We let this be the angle. The cos is equal to the opposite. Sorry, cos is equal to adjacent. 4 over hypotenuse. Based on your knowledge of Pythagoras, this is 3. So sine A is equal to 3 over 5, which is equal to 0.6. And if you get the sine of this angle, maybe just jot that down. That's also equal to 0.6. So just two ways to do this same question. Good trig knowledge required, good algebra skills, loads of skills required here before moving on to number 11. We have R, P and Q. So we're just going to take our time always. We have loads of time to read these questions. There's never a rush. Show the angle between R and P is the same as the angle between R and Q. Okay, so we have two things, R and P first. So let's look at R and P down here. So the cos of theta, or we'll just get the inverse cos straight away. Let's jump to that step. You should be good at this by now. So the dot product on top, 6 by 2, 12, plus 2 by 4. Now I think probably good maths not to just show the 12. Let's just show the 6 by 2 because the calculator is going to do it for us. Plus the 2 by the 4. And this is just what good mathematicians do when they know they can do it in one step. Divided by the magnitude. So you're looking at this R and you're saying 36 plus 4 square root 40. That's what your brain has to get good at. If it doesn't, stop watching these videos and do something else. When you look at P, you say 4 and 16, and you say square root 20, 4 and 16. And the inverse cos of this is going to give us, type it directly the way you see it into your calculator. Coming in at 45 degrees. That's the angle between R and P. Just going to jot that down for a bit more information. And then P and Q, is that next? R and Q. So R and Q. Are you confident enough to do it in one step? The inverse cos of, let's have a look. R and Q, just take your time. R and Q. So R, we're looking for the dot product between R and Q. So we have a 6 by 2 plus we have a 2 by a minus 1, and the magnitude of these guys, R is not going to change, it's root 40, and Q is going to be 2, 4 plus 1 is 5 here. You're looking at 2 squared and 1 squared, root 5. If you type this into your calculator, you're going to get the angle to be also 45 degrees. So QED, we've shown that they're the same. Last part, show that P is perpendicular to Q, so we need to show that dot product is equal to 0, and you've practiced these a few times. You'll be able to roll that off the tongue. It's just like learning a new language. Until that, you'd never know what dot product was. So or perpendicular to Q, no sorry, P perpendicular to Q. So let's have a look at that here. Is the vector P perpendicular to the vector Q? You're going to say the dot product is 2 by 2 plus 4 by minus 1, which is equal to 0. Therefore, the vector P is perpendicular to the vector Q. Just finally in this video, maybe if I asked you to make up a vector that was perpendicular to another one, just take two random, 2 plus 3. Now, what would we have to multiply this by to get a perpendicular? Well, let's say I multiply the 2 by 6 to get 12, because I can see the 3 will go into 12. So we'll have to get these to cancel. So this will be 6i minus 4j would give me minus 12, wouldn't it? 2 by 6 plus 3 by minus 4. So you should be able to come up yourself with a couple of vectors that are perpendicular to each other. Then you have brilliant knowledge of this topic before moving on to the next part.